Alright, my video cut off on that last one. Let me finish this one up. So we're comparing, or trying to see if there was a relationship between the liquid's molecular weight and the boiling point. So we could put those tables side by side. So let's take a look at, say, methanol. Got a molecular weight of 32. It's got a boiling point of 64.7. So you might think initially that yes, there is a relationship. We've got the lowest boiling point and the lowest molecular weight. However, if we keep going and look at the next one, what's the next highest molecular weight? 2-propanol. Okay, so my boiling point increases. So that's good so far. And then take a look at the next one. 2-butanone. Molecular weight 72. But notice my boiling point decreases. Okay, and so there actually isn't a set pattern there, which is why D is your best answer on that one. Alright, and then that's going to bring us to the last passage here where you missed 3 in a row. So let's take a look what's going on here. We have a basic, looks like a solubility problem. So on the y-axis we're looking at water depth, and then we have a point of saturation. So basically what that means is at a water depth of 4 kilometers, that water is saturated with calcium carbonate. If you would then take a look at the actual question, it asks you calcium carbonate often precipitates out of seawater in areas where the seawater is shallow, which is less than a kilometer. Well, according to figure 1, this most likely occurs because seawater in those locations what? Alright, let's take a look here. So here's your kilometer, and you can see that we are super saturated at that depth. So basically what that means is it's going to precipitate out. Okay, so right away when you're seeing that word precipitation, the only reason you'd have any precipitation is if you were supersaturated. That is, that solution does not have the ability to dissolve any more of this solute, calcium carbonate. Okay, so that's why H is going to be your best answer there. Alright, according to figure 1, above what maximum depth is seawater supersaturated with respect to that same solute? So we go back to figure 1. Okay, we can see that our saturated point again is 4 kilometers, and you can see that it's as soon as you go any shallower than that, you're supersaturated. So essentially you have a very fine point in which you transition from supersaturated to unsaturated. Okay, as soon as you go beyond that 4 kilometers, you become unsaturated. So, that being said, above what maximum depth is seawater supersaturated? So, at 3 kilometers, are you supersaturated? Yes. And you are supersaturated all the way right until that 4 kilometer mark. If you go 4.5, you're actually undersaturated or unsaturated. So 4 kilometers is going to be your maximum depth of being supersaturated. So again, that's why C is going to be your best answer. Alright, then the last question. Figure 1 shows the rate at which calcium carbonate dissolves, increasing the most between which of the following depths? Okay, so we know there's going to be a relationship between temperature and solubility, or the rate at which it dissolves. And with solutes, generally the warmer it is, the better it dissolves. Let's take a look here. What's going on? So as we go deeper, the rate is becoming greater. But if you notice, over these first kilometers, I didn't really increase my rate all that much. Actually, all the way to about, maybe 4.5. Once I get beyond 4.5 kilometers, notice what my rate does. It really increases over a period of this kilometer here between 5 and 6. Okay, my rate here, which is plotted on this type, this x-axis here, really increases between 4.5 to 6. So let's go back to that question. What are we looking for here? The rate at which calcium carbonate dissolves increases the most between which depths? All right, 3.5 and 4. No, that's all pretty much a constant rate increase there. 4 to 4.5. Not really. I'm still getting that same rate that I'm getting up here. That same rate of increase, actually, the same there. 4.5 to 5. 4.5 to 5. Now you're starting to see that rate increase here, but it's not until 5 to 6 that it really slides towards the right, which is a higher rate of dissolving. So between 5 and 5.5 would be an adequate answer.